and cotangent. Good.
And if you did not remember that, let's write it over here. So, ka, toa. And let's see if we remember what this stands for. The S stands for what? Sine. So sine is what? Very good. That's what the O and the H stand for. Cosine is what? And tangent. Alright, so that's 3 of the trig functions. Sine, cosine, tangent. And y'all said the other one was what? Alright, secant goes with which one? Cosine. What's the abbreviation for secant? SEC. Very good. It goes with cosine, their boyfriend and girlfriend. What sine's boyfriend? I guess she can be a girl. Cosecant. What's the letters that stand for cosecant? Very good. And who is tangent's boyfriend? Cotangent, which is COT. And the reason I put them right under each other and the reason they're boyfriend and girlfriend is because cosecant is what? Opposite of this. So instead of opposite over hypotenuse, it's what? Very good. That means secant is and cotangent? Very good. This one? This is CSC. And this stands for what? Now get in the habit. Starts with a C, so think cosecant. Starts with an S, so secant and cotangent. And this is sine, cosine, tangent. Those are the 6 trig functions, and that's what we're going to be dealing with for the next 2 to 3 weeks. You'll have them memorized by then. Alright, so before we find all of these trig functions, we have to identify what's our opposite, adjacent, and hypotenuse. So the first thing we'll do is draw this point on a coordinate plane. You can just make one since we don't have one. So negative 12 is our x value, so it's going to be somewhere way over here. I'm not going to actually draw 12 tick marks, but you can if you want to. And then the 5 is going to be 5 up, so somewhere right here. Alright, you always draw a line from the origin, and what is the origin? 0, 0 to this point. That's the first thing you want to do. Alright, obviously if we're doing sine, cosine, tangent, adjacent, and hypotenuse and opposite, we're dealing with what kind of shape? So let's make one. Draw a line straight down. Now theta, do y'all remember where that's going to be? Closest to the origin, which means that's what it meant by terminal side. Closest to the origin. So here's theta, and theta is just a fancy word for our what? Angle. Alright, they give us negative 12 and 5. How do I know where to put that on my triangle? That's our x value, right? So it's this, horizontal, very good. And where's our y value? Very good. How do we know that? Because this is our x, this is our y. What are we missing? Our hypotenuse. And how do we find that? What's that called? Yes, Pythagorean theorem, and write it up here if you didn't know it. PT, a squared plus b squared equals c squared. Which letter are we missing? C squared. And does it matter which one is our a and b? Nope. Alright, so let's fill it in. We have 5 into a, so it'd be 5 squared, which is plus equals, I'm just going to put c squared for now. This is what, like y'all said, equals c squared. So what is c? Very good. How come it's not, anytime we take square root, we put a plus or minus. How come it can't be negative 13? Go ahead. How come it's not plus or minus 13? It's a what now? Not really. This line is the distance between these 2 points, right? Can distance ever be negative? No. Very good. Alright, and this C is the same thing as our what that we just found. Okay? Which one, negative 12 or 5, which one's opposite, which one's adjacent?
Opposite is 5. Yeah.
How'd you know that?
Because it's opposite of theta.
Good. It's opposite of theta, so 5 is our opposite. 12 is our adjacent because it's right beside theta. And that's how it's going to be for every single one. A is always going to be your X. O is always going to be your Y. So do we have to draw this point on this one? No. Which one's going to be our opposite? And adjacent? You can remember it because A comes first in the alphabet, so it'll come first in your coordinate point. Alright, now let's get to work. We're finding the 6 trig functions. So sine is opposite over hypotenuse, so sine theta is going to be what here? Very good. Let's go ahead and deal with sine's boyfriend. What's sine's boyfriend? Cosecant. So what's cosecant theta? Good, you just flip-flop them. What's another trig function? So cosine theta would be cosine is adjacent over hypotenuse, right? So it'd be what? Negative 12 over 13. Who's cosine's boyfriend? And what's secant going to be? Very good. Does it matter if the negative's on top or bottom? Nope. Alright, tangent theta is opposite over adjacent. So what? 5 over negative 12. And then tangent's boyfriend is going to be perfect. Those are our 6 trig functions. Did y'all remember that from pre-cal / geometry?
Are we going to have to do another circle?
Yes. That'll be in like a week or 2.
Like memorizing.
And then we have the table.
Yes. And I'll show you the hand trick. That's what I always use is the hand trick. Alright.
What about the...
Next one. What's our first step on number 2? We don't have to graph it, do we?
No.
We just need the what?
The
Hypotenuse, so we just use what? Yes. Tell me how to set it up. So, shorter. Which is
9
plus 49 equals c squared.
Yeah.
So 9 plus 49. So square root of 58. Yes, but we don't want to put that. We want to leave it in radical form. But can we simplify this radical?
Yeah.
How could we? Like we'd have to find what? Perfect squares that go into it. Okay? Think of, or I'll let you try on your own, but what would be the easiest perfect square to check? 2's not a perfect square. But 4 is. Can 4 go into 58? Alright, next perfect square is 9. Can 9 go into 58? Alright, last one, check for 16. Can 16 go into 58? Nope. So it looks like we can't simplify it. So our hypotenuse is what? Square root of 58. Alright. So sine, we'll start there, is what over what? So it'd be what? Can we leave it like this? Nope, because of the what? Radical on bottom. So how do we get rid of it? Multiply by square root of 58. Good. So on top, we'll have what? On bottom? Very good. Alright, so for its boyfriend, which is what? Cosecant. Which would be easier to flip? This? Then we'd have a radical on bottom. Or the original? Good, because if we flip this, we just have what? And we don't have to change anything. So everybody get what I'm saying? If you flip this, you'd have to, go back and get the Square root of 58.
Miss Horton?
Yes.
Hey, did Victor Turret make it in?
No, ma'am. And Logan, it says he's on a field trip, but he's here.
Or what's his last name?
Modern.
He did not go.
I don't know
No.
anything about the trip.
Okay, I'll fix it. Thank you.
Okay. All right. Next one, let's do cosine theta. Now, cosine theta is going to be adjacent over hypotenuse. That would be what? 3 over root 58. Do we have to write that and get rid of the radical on bottom? What's the shortcut? Wouldn't it be the same exact thing as what? Sine, except instead of 7, there'll be a what? 3. Very good. I'm trying to save y'all some energy. Now what about, what's this boyfriend? Secant. And wouldn't it be the same as this boyfriend except what? 3 on bottom. Good. Square root of 58 over 3. Next trig function would be what? Tangent, and it is what? Very good. Its boyfriend would be, very good. Questions? Alright, one thing I want to point out, and this will help you on the next one because you're about to do it on your own. If your points x and y have something in common, meaning like they have a common factor, you can simplify it before you start finding sine, tangent, cosine, all that. So like these, do 12 and 5 have anything in common? Do 3 and 7? But do these? We can rewrite this as what? And that would give you smaller numbers if you want to do it that way. But go ahead and find all the 6 trig functions for number 3 on your own. Let me know if you need some help.
What was the secant for the last one?
Square root of 58 over 3. I'll leave it up there.
Alright, let's start going over it.
I saw a lot of y'all just left this as 5 and -5, which is fine. You'll get the same thing. Do y'all, when I go over this, do y'all want me to work with 1 and -1 or 5 and -5? -1? Okay. So that means this is our what right here? And this is our? Okay. And so how do I find my hypotenuse? Good. So we have what? 1 squared, which is 1, plus... Good, because -1 squared is what? Yes, a lot of y'all had like -1 right here. Remember, when you square a negative, it's always going to be positive. Equals c squared. So that means we have what right here? Equals c squared. And we have to do what here? So we get c equals, which is the same thing as r. Yes. If you did not simplify this to 1, you'd get like square root of 50. And then you'd have to simplify that to 2 square root of 5. So if you don't simplify at the beginning, it's going to be more work on you. Does that make sense? Like, you'll just have to keep simplifying every time you do a trig function. But if you did, that's fine. Just stay with me. Alright, so we have all our O, A, and H. Now let's set up for sine. So sine is going to be what? Opposite over what? Okay. If I use these -1 and 1 to find my hypotenuse, what do I have to use here? Same thing. So what's going to be on top?
-1 square root c.
Alright, now I have to get rid of that, correct? By doing what? By? Good. So on top I would have over. Very good. That's one of them. His boyfriend is who?
Negative square root, or
Cosecant. And what's that going to be? Yes, you just flip the original, so it'll be negative square root of 2. Alright, give me another trig function we can find. Cosine. Isn't it going to be a lot like sine? Except what? Very good. So square root of 2 over 2. It and secant, its boyfriend, going to be a lot like this one? Except what? Positive. What about tangent? Good, because opposite over adjacent. What about cotangent? Same thing. Good. Y'all have any questions? Yes.
I'm confused when you got
The negative ones here?
no, like under the yeah.
Okay. What I did to get the 1 and 1, they both have what in common here?
Miss Horton,
Yes.
did Antonio Brown make it in?
No, ma'am.
Thank you.
They both have what in common? Yes. So what I did was just divide both of them by 5.
Where does the numbers that look familiar? Do we use them somewhere else?
Yes, we do. Theta is 45 degrees.
I saw it's on the chart.
Yeah.
On the test, when we write out sine, will we have to write theta too?
I won't count off if you just put sine equals this. That's fine. Any other questions? Alright, so that's finding the 6 trig functions given a point. Alright, now we're going to talk about quadrants. And I only drew 3 for a reason. I want you to write this at the top to help you remember. You know how you have SOHCAHTOA? Here's another acronym to help you remember quadrants and their signs. All students take calculus. All students take calculus. Not true, but it's going to help us remember. And I want you to underline the first letter in every word. So underline the A, the S, the T, the C. So notice how some of our values up here, like for this one, cosine and secant are positive, but sine and these are negative. That depends on what quadrant your angle is in, or what quadrant theta is in. For the first quadrant, which is where on here? Top right. It goes 1, 2, 3, 4. It goes counterclockwise. Y'all remember that? Go ahead and label all of them just to help you. Q1, Q2, Q3, Q4. Same thing here. Goes counterclockwise. Alright, the all stands for the first quadrant, Q1. That means in quadrant 1, all of your trig functions are going to be positive. All the values, sine, cosine, tangent, all their boyfriends too. This is for the second quadrant, quadrant 2. The S stands for sine. So in quadrant 2, only sine will be positive, and its boyfriend, which is what? Cosecant. Everything else in quadrant 2, tan, cosine, their boyfriends will be negative. The T is for quadrant 3, and it stands for what? Tangent. So in quadrant 3, tangent and its boyfriend, which is cotangent, will be positive. And then the C stands for quadrant 4, and it stands for which basic trig function? Cosine. And its boyfriend, which is secant. So all students take calculus. All of them are positive, sine and cosecant, tangent and cotangent, cosine and secant. Did y'all learn that in pre-cal? They're saying yes. Colby said no. I'm going to have to talk to Mr. Hester about that one. Alright. So for these 4, 5, and 6, all it's saying is name the quadrant. 1, 2, 3, or 4. Based on these conditions. Okay? The first one says sine of theta is what? Meaning that this is what? Negative. Where is sine negative at? So tell me, where is sine negative at? Which quadrants? 3 and 4. Because it's positive in 2, we know all of them are positive in 1. So I'm going to put 3 or 4 underneath. Alright, this one says cosine is greater than 0, meaning cosine is what? Positive. And where's cosine positive at? Where else? Nope. Good. Only 4 and 1. 4 or 1. So which quadrant satisfies both of them? 4. Very good. Alright, Darian. This one says tangent is greater than theta. That means they're saying tangent is what? Greater than 0, excuse me. Tangent is what? Just positive or negative? Good. Now look at your quadrants. Where's tangent positive at? 3, right? Or what? 1 or 3. Alright, this is saying sine is what? Negative. And where's sine negative at? 3 or 4. Good. So which one satisfies both?
3.
Good. Go ahead and do 6 on your own. Let me know if you have a question.
Mr. Hamilton?
Wrong room.
Sorry.
So if it's positive, you automatically put 1 or, and then where's tangent positive at, right? So for this one, it's positive here, right? And here. So what's got to be here? 2 or 3. Right, where is tangent positive at?
The other side.
This one and what?
Alright, what's quadrant is the answer? 2. Y'all have any questions? Yes, can I explain? Yes, okay. Then this says that cosine is what right here? So, negative. This one says less than, so. Alright, so I'm looking at cosine. Notice it's right here, right? That means that cosine is what in this quadrant? Positive. And also it's positive in which one? 1. All of them are positive in quadrant 1. So cover them up and you'll have what? 2 or 3. Yes, so this one tangent is positive here, Darian, and where else? Yes, so if I cover them up, it's got to be what? 2 or 4? Which one satisfies both? 2. That make more sense? Okay. Alright, we just got 2 more and then we'll be done. Alright, this one's saying find the exact values of the remaining trig functions. How many trig functions are there in total? We have 1, so there's 5 more. They give us that cosine is 3 over 5, so that means 3 is our what? Adjacent, good. And that 5 is our what? Good. Alright, and think about it. If it's in quadrant 4, what is the only 2 trig functions that are going to be positive? Quadrant 4. Look at your paper. It's going to be what? Cosine and secant are the only ones that are going to be what? Positive. The rest of your trig functions will be negative. In quadrant 4, only cosine and secant are positive. Alright, we just have to find what now? Opposite. By using what? Good. But this time it's going to be a little different because we have what 2 letters? Yes, sir. Yeah, go ahead. We have what 2 letters?
B and C.
Yes. So tell me how to set that up.
A plus 9.
A plus 9. Okay, yeah, A plus 9 equals?
Plus 9. 25.
Good. Because A squared, we don't know. I'm going to put squared by it. B squared, she picked this to be B, which is fine. C squared equals 25. How do we find it? And we get,
A squared is 16.
so A equals, think about it.
4.
Think about it. Why negative 4? We knew it was negative 4 because of the other functions have to be positive. See that? If you put positive 4, it's fine. I'll show you how you can check. Alright. Alright, so this is our what that we just found. Opposite. You can put 4 or negative 4. It doesn't matter because I'm about to show you how to do it if you were to put positive 4. Alright, sine is what over what? So say if you just had 4. Over what? Hypotenuse. You know it has to be negative because it's in quadrant 4. And in quadrant 4, is sine positive? Nope. Has to be negative. Do you have a question, Kaya? Okay. What about its boyfriend? What's it going to be? Very good. Alright, moving on to, do we have cosine already? Yes, so what's its boyfriend? Secant, and it is going to be 5 over 3. What about tan? Negative 4 over 3. Very good. And cotan? Very good. Y'all have any questions so far? You are going to do 8 on your own, and as soon as I have checked it, you can pack up. One thing I want to point out, 90 to 180. What quadrant is that? 90's right here, right? 180's right here. So it's in quadrant what? Okay. So you can mark that out, put quad 2 if you want to. Go ahead and try it on your own. Let me know when you're done so I can check it.